In today's note, we're going to be looking still at quadratic functions, but we're going to look specifically at the factored form. So just to review, remember the factored form in our last note we talked about is the quadratic function with the equation y equals a times x minus r times x minus s. And the key things that these letters or these variables represent, we have our a value, which is, as we talked about before, our step pattern. It does control the direction of the opening as well. And again, this is the same as it is in vertex form, as it is in standard form. The a value that can be found in all equations has the same or tells the same information. The r and the s value, those values, or more specifically, as we talked about before, the opposites of those numbers or of those values are the zeros of the parabola. Right? So again, remember, because they're in the brackets, you're looking for the opposite of what they actually are. And those are the two key things that our quadratic function in factored form tells us about our quadratic or our parabola. So let's just look at this table and let's look at trying to find the key information from it. So the first thing are zeros from this equation. Remember, our zeros are the two numbers in the brackets with x. They are going to be the opposite of what we see. So because we see -3 first here, our first zero is actually +3. And because it's a 0 or an x-intercept, that means the y value is 0. Our second one is going to be -5, because when we see the +5, we have to remember that's the opposite of that. So that means that our second zero is -5 and 0. The direction of the opening, well, the direction of the opening, when we look at the a value, because it's positive, that means it opens up. And then our step pattern, remember our step pattern follows the form 1a, 3a, 5a. That's the general form. Let me just make that a different color. That's the general form. So our a value in this case is actually 3. So what that means is it's 3 times 3, or 1 times 3, 3 times 3, and then 5 times 3. Again, just filling in our a value we see here with our pattern. So we get 1 times 3, and then 3 times 3, and then 5 times 3, which works out to 3, 9, and 15. So that's just a long way. You don't have to show that. You just have to show this last step of the 3, 9, 15, but just wanted to show where we got that from. Right, moving on to the next equation. Again, our zeros, the two numbers in the brackets, but the opposite of what we see. So -2, 0, and -6, 0 are two zeros. Again, I'll go through and highlight those. So again, remember, it's the opposite of those signs. The direction of the opening in this case is going to be down because of that negative in front. The negative value means it's down. And the step pattern, again, following the same idea, 1a, 3a, 5a. Instead of this case, we have -1. So our step pattern becomes -1, -3, -5. For our zeros in the next equation, here we have +2 and 0 and -8 and 0. Again, just getting them from the two numbers in the brackets, just the opposite. The direction of opening in this case is going to be up, because again, the number in front, even though I can't see it, there's an invisible 1, so that means it is positive. If it was a -1, it would be something like the last equation where we'd see the negative out front. So that means because it's 1, my step pattern just is 1, 3, and 5. What we're going to do next is learn how to plot our quadratic functions given the factored form. So what we're going to start off with is we're starting off with finding the zeros for our quadratic function, right? So we have the function here, y equals negative x plus 2 times x plus 4. So again, our two zeros are going to be negative 2, 0, and negative 4, 0. Again, just taking the opposite of the two numbers that we see, and we want to plot them. So negative 2 and negative 4. So those are my two x-intercepts, or my zeros. Now, what's important to note, we can't really draw our quadratic base or our function based off of this because we don't know what shape it looks like, how far up or how far down it goes. But what we can do is we can calculate and find what the vertex is, right? Because the vertex is located in the middle of the zeros. So I need to find the middle of these two numbers. Now, in some cases, you may just be able to look at them and identify what that is. But if you can't, what you can do is take those two numbers. So you can say your x1 plus your x2 and divide that by 2. So basically you're finding the average of your two numbers. So negative 2 plus negative 4 divided by 2 equals negative 6 divided by 2 equals negative 3. So that right there, that negative 3, is the middle value of your vertex, or the x value of the vertex. So that means this value right here is actually our AOS. So somewhere along this vertical line, our vertex is going to be, right? Because remember from the last note that the x value of the vertex was also the AOS. So we know our vertex is going to be somewhere on this line. We don't know where though. The second step though is to take the middle value and sub it into the equation for x to get the y coordinate. So I'm going to take my original equation, y equals negative x plus 2 times x plus 4, and I'm going to take that x value that I just found and substitute it in. So it becomes y equals negative times negative 3 plus 2 times negative 3 plus 4. Y equals negative times negative 1 times positive 1. So negative 1 times negative 1 is 1 times 1 is 1. So that means that my vertex is going to consist of my x value of negative 3 and the y value of 1. So my vertex is actually negative 3, 1. So I go over to negative 3, go down to 1, positive 1, not negative 1, and put a point there. So that is where my vertex is. I know my two x-intercepts. Now the last step I can do is I'm going to use, I've plotted the vertex already, and I'm going to use the step pattern to sketch the parabola. So remember, our step pattern follows the pattern of 1a, 3a, 5a. If I go back up to my original equation, the a value is negative 1, so that becomes 1 times negative 1 times 3 times negative 1 times 5 times negative 1, which gives me a step pattern of negative 1, negative 3, negative 5. So I can use that step pattern to help me plot my next points. Again, remember the step pattern means you start at the vertex, you go to the left or the right one, and then up or down, whatever your step pattern tells us. In this case, because it's negative 1, I'm going to go down. That takes me right to my x-intercept, which is good. I already know I have a point there, but it confirms that my step pattern is correct. Next point, I'm going to go over 1 again. So that was down negative 1, and now I'm going to go down 3. So 1, 2, 3. So that's down 3. I'm going to put another point there. I'm going to go over 1 again, and this time I'm going to go down 5. So 1, 2, 3, 4, 5. So I went down 5. There's my next point. Now I could do that same pattern on the other side. However, because I know it's symmetrical, I can just draw in the points at exactly the same spots, just on the other side of this axis of symmetry. Now that I have all those points, I'm just going to connect all the dots as best I can, and there is my quadratic. So let's go through some practice again and try to figure out, well, actually I'll go through one example of all of them. So there's a couple steps to each one, but I'm just going to go through one, and then you can try the rest on your own. So in the first one, direction of the opening. So the direction of the opening, I'm looking at that A value. So because it's a negative, it opens down. The step pattern is still focusing on that A value because it's -2. That means it's 1 times -2, 3 times -2, and 5 times -2, which gives me a step pattern of -2, -6, -10. And my zeros, again, the zeros are the opposite of what we see in the brackets. So I have +1, 0, and then the other point is -3, 0. So those are my two zeros. In number 2, I want to calculate the location of the vertex for each of the above parabolas and then sketch them. So I'm going to work on finding the vertex. I know that the x value of the vertex has to be between the 2 points. Remember, the vertex is an x and a y value. I don't need that. We already have on the side over here. So I need to find the middle of my 2 x-intercepts. So I'm going to add them together. So 1 plus -3, and then divide by 2 to find the middle. So I get -2 divided by 2, which equals -1. So I know so far for my vertex, the point is -1 and then something else. Again, we talked about to find the y value. I'm going to take my equation, y equals -2, x minus 1, x plus 3, and substitute this x value into the equation. So y equals -2 times -1 minus 1 times -1 plus 3. Okay, y equals -2 times -2 times +2. And I get, when I go through and multiply, I get y equals 8. So that means the coordinates of my vertex are -1 and 8. So I do need to sketch that. I will sketch it first, and I'll go back up and try to state the vertex form for that equation. So we know for the first equation, the vertex was at -1 and 8. So I go over to -1 up to 8. So there's my vertex. This is -1, 8. Now, if I go back up to the equation, and I'm looking at the step pattern was -2, -6, -10. So that means that I start at one point, I go over 1, and then I have to go down 2 to get to my next point. To find the next point from there, because there I went down 2, I go over 1 again, and now in this case I go down 6. And there's my next point. And for my last point, I go over 1 again, and in this case I go down 10. And there's my last point. And I can just repeat or copy those same points on the other side, because it does form it does have that symmetry. I can also double check. I also probably could have plotted my x-intercepts right away, these 2 points here, because those ones I already knew, but based on my step pattern, I was able to find them anyways. But it does just help to clarify that it is the right step pattern. Right now, it doesn't need to be perfect, but as long as you're trying to connect the dots as much as possible. So that was equation 1. So now that I've what I want to do, I'm going to go back and I want to state the vertex form for each equation. Right? I have enough information now to be able to state the vertex form. If we remember, the vertex form is y equals a, x minus h squared plus k. So when I'm going through to write my vertex form, I can start off y equals, the a value stays the exact same. So the a value in this previous equation, or this equation when we saw it in factored form, was still -2, so that stays the same. The x we're not changing. The minus h, again remember the minus h comes from the vertex, because the vertex, when in vertex form, is just hk. So the h value of my vertex is -1, but when it goes into the equation, it's the opposite, so it's +1. And the k value just stays the same, so it's +8. So that means the same parabola in vertex form has the equation y equals -2 times x plus 1 squared plus 8. So the key things from this note is, again, just recognizing the important parts of the quadratic function when it is in factored form, being able to graph the factored form by finding the vertex, and then once I have that graph and I have that information, rewriting the equation but in vertex form.